So, I'm going to talk to you today a little bit about identity and access management and the common expression language, and give you a bit of introduction in terms of what we do at Exoscale and why we picked Cell and how it's been for us, basically. I'll also give a bit of a dive into what Cell is. So a bit of background on me. I've been doing this nearly 20 years now in terms of development. Worked at many places, but I came to Switzerland in 2018 to work for Exoscale, who are a cloud provider. And I've worked across quite a bit of the stack actually at Exoscale in terms of the front end for a little bit, the API, the identity layer on top of the API, back-end orchestration, managed Kubernetes, the load balancer. So I've worked on quite a few things there. In terms of Exoscale, as I said before, we're a European cloud provider. We have zones in the places that are in red on the map, and we have most of the services you would expect. Managed compute, S3, compatible object storage, block storage, and so on. And Exoscale's been going since 2013 publicly. So I will start off just with a bit of a background in terms of what IAM has looked like at Exoscale. And when I talk about IAM today, I'm really talking about authorization. So for authentication, we tend to use HMAC or tokens, but I'm not really talking here about are you allowed to call this endpoint. I'm more talking about you've passed this check, you can call this endpoint, but what can you actually do when you're through this stage? And how fine-grained we can go with that. So just to give some more background, that's not a real key, by the way. You can try it if you like. But back in 2013, we were using CloudStack mostly, and you had one key and one secret per user, and that could do everything within an organization. You can think of an organization as an account, if you like. So yeah, it wasn't great, but that's what it was for 5 years. In 2018, we introduced IAM v1. It's internal that we call these v1, v2, v3. You won't see it on the public docs, but basically here, back in 2018, we decided that we'll allow you to limit a key to a subset of operations. So listing virtual machines or listing zones, but perhaps you can't deploy a virtual machine. And we also decoupled from users, so you could have as many keys as you wanted without adding users for CI access and so on. A policy might look like this at the time. So we had the product / then the command that you were calling. And basically, we'd give a set of operations that you were allowed to call. So that's listing zones, listing virtual machines, listing buckets on our object storage. Or for DNS, we have this wildcard operation where it's any DNS call. One of the biggest features from customers at the time was that I've got this key, but I want to restrict it to one S3 bucket, effectively. So we did implement that for object storage, but we didn't do resource restrictions for anything else. So it was a big improvement on what we had, but it was still pretty limited. 2020, we had a new API, and basically everything got renamed, but nothing really changed in terms of functionality. So in 2022, we kind of reviewed this, and we said, actually, what we would really like is to do really fine-grained restrictions on these API calls. So if I'm setting up an API key that's going to be used from CI, I want to be really specific about what permissions that key has. That was our main goal. And we also wanted to say, rather than just having permissions that are granted, for example, I can call this operation, we wanted to introduce permissions that could deny things as well. So if I've got 100 API calls, with the previous version, I would have to, if I wanted to allow them all but one, I'd have to add 99 operations to my key and not include the other one, which is not great, right? Ideally, I'd like to say, deny this one thing, but allow everything else. And our solution to this basically was we came across the common expression language, Cell, which was used on Firebase at the time. And this is the homepage for Cell at cell.dev. And basically, the whole idea behind this is that you want an expression that's provided by some user, okay? And you want to evaluate that within your application. And of course, it sounds risky, but the whole design behind Cell is that it's meant to be safe for you to run this locally, right? It's not Turing complete, and it's guaranteed to terminate. And it's also guaranteed that it can't access things outside of the input that you provided. So it's kind of like a pure function, really. It's also extensible. So you'll see in some examples that it does get extended, particularly in Kubernetes. But yeah, just out of interest, has anyone used Cell before? Yeah, one person, cool. Has anyone heard of Cell? A handful of people, cool. All right, the other thing to mention, it's not like a fully blown programming language, right? They're typically one-liners or short expressions that we're going to evaluate. In terms of the language itself, you have things that you would expect in a programming language, some numerical types, Booleans, strings, lists, maps, and you've also got timestamps. You've got bytes as well, and you can deal with protobuf as well, protobuf types. You've got some basic equality and addition, subtraction, and so on. You've got ternary statements. And then there's some built-in functions, for example, if you want to check if a list contains some item, if a string starts or ends with a particular value, the size of a list, and so on, some regular expressions. And you've also got macros, which is how you can extend the language as well. But if you're familiar with functional programming, you can do things like filter and map on a list, and then perform some check against that list. So in terms of actually evaluating this stuff, there's some parsers provided by Google. At the time, there was only the Go parser, actually, an evaluator, when we were using this. There is since one in Java and one in C++. We use Clojure typically on top of the JVM. So at the time, we wrote our own, or our previous CTO wrote his own parser for this, probably in a weekend. He's a pretty clever guy. But anyway, we've been using that since. Maybe in the future we might switch to the Java one, but it's been good enough for now. And if you search online, you'll find libraries in lots of languages. In terms of who uses Cell, I'm going to give some examples. So Firebase was the place we first saw it, probably 3 years ago. And you can see, if the text is big enough, hopefully, to the right of these if statements, you've got Cell expressions. So true is a simple Cell expression, or request auth UID equals request.resource data author UID. It's used in Google Cloud for IAM. It's not the only way of using IAM in Google Cloud, but it's an option if you want to write some more advanced expressions. For example, like a name starts with a certain prefix. It's used in Istio for some things. Like, for example, I've not actually used this. I just came across this example today. But yeah, you can restrict things with Cell. I'm not going to go into that. In terms of Kubernetes, I'd say it's a relatively new addition. But you can use this for custom resource definitions, admission policies. And there's a lot of extensions with Kubernetes that are not in the standard Cell language. If we look at some use cases, like the sort of why would you use Cell in Kubernetes, really it comes down to custom resource definitions. And the previous way you had to do this was to provide a webhook. So the Kubernetes API server is going to call back to your application to do some validation checks before deciding whether to accept a request or not. With Cell, it's going to be evaluated on the API server, and you don't have to deal with callbacks. So it's much nicer, really. And there are some examples. This is, I think it was in beta in 1.25, but since 1.29, you can use validations like this to validate that a field's not empty, for example, or has a certain prefix, or is within a given range if it's an integer. Another example for validating admission policy is you might want to write an expression that limits the number of replicas that a deployment can scale to. And that's, for example, this call trying to scale to 3 replicas would fail with this validation. And you can also provide an error message, which is nice if that validation fails, so you're getting something readable back. One more example, they have match conditions and validations, and this is also using Cell. And basically, all of these things have to match for a request to be accepted in this example. That's since Kubernetes 1.30. There might be some parameter you have to enable for that to work on your API server. And this is something I came across whilst preparing this talk, actually. I was not aware of this. I'm pretty sure it did not exist when we were looking at Cell a few years ago. But it's the Cell Playground by GetUp. And it's quite a nice example because you've got input on the right, which can be JSON or YAML. But you can think of this as the input to your function. You've got your expression on the left, which can use that input. So you can see object.href here. IsURL and URL are actually extensions from Kubernetes Cell. But you can write some really fine-grained expressions, evaluate this, and on the bottom right, you've got the output. And you also have a cost that's 36 there. And basically, that cost is going up and up as you start to evaluate your expression. And in Kubernetes, they have limits on the cost, basically. So you can stop execution if you reach a certain cost. So if someone does manage to write a really expensive Cell expression, you can just abort this, actually, after a certain cost and reject the request. There are ways on Kubernetes that you can set limits on the max items or things within a list to stay within a cost. Anyway, I'll give an example of what we do at Exoscale for this. So we have this public API that you can manage all your resources with. And basically, the user provides some expression. So here we have operation equals reboot instance, and resources.instance.name starts with AJK, my initials. We then have an API request. So it's a put request to instance/id/reboot. And then in order to prepare the input for the Cell expression, we take some parameters from that request. So the instance ID, the operation name. We take some parameters from the context, so the zone that you call this operation on, because our API is per zone. We take the timestamp of now. We take your source IP. And then we also go and load some things from the database, if relevant, for your request. So here you've got an instance ID in the request. We load that instance from the DB. We select certain fields that we decide to make available. And then basically all of that is available when you come to write the expression. So the same example with a reduced input, so it fits on the screen. But we've got that operation, we've got the zone, we've got a resource with a name and a label. And we have the expression on the left, operation equals reboot instance and the name. And you can see the cost as well. But typically, that's how we use it. You can write huge expressions if you want. And in practice, there's a lot more input than you see there. But I'm going to go through a few examples. I think the best way to get a hang of this is really to look at lots of examples. Another one here is I've limited the input, so we've just got an operation and a source IP. And then I wrote the same thing roughly in a few different ways. But this first expression here, that's basically all we supported on the previous version of IAM, because it was an operation in a set. That's all you could do. But in the newer version, we can say, actually, the operation starts with get or list. So effectively, it's a read operation. Or we can say, actually, your source IP is in this set. So we're only allowing get and list calls from this set. Obviously, this one's redundant in this example because it's going to match on the first one anyway. So that's not really going to do anything. But just an example. Another one here, we actually can convert from one type to another in Cell as well. So you can convert from a string to an integer and so on. Here, I provide a size of 10, and I'm doing a command to scale an instance pool, which is basically just a pool of instances. You give me a number, and we'll create that number for you. But we can restrict in the range, like you saw in the Kubernetes example. And here it fails, because obviously I've passed 10 instances, but I'm only allowed up to 6. The conversion's not actually applying here because I provided an integer, but if I'd provided size 10 as a string, this would cast it and then do the check. Okay, another example, I mentioned parameters and resources. In terms of when you're writing your expression, it doesn't really matter, right? You've got input, and where that input comes from is irrelevant to you really as a user. But here, parameters in our terms typically come from the request. Resources are coming from our DB. And then in your expression, you can write things like limit to this operation, so only allow creating DNS domain A records for this given domain. A few more examples. So we start to get a little bit more advanced now, but here we're using size to check that there's only one IP filter in this list. And we're checking that the IP filter that is provided is this one exactly. With the next one, ipfilter.all, we're actually looping through all of the IP filters provided and checking that they match this predicate. And likewise, you can do, does this one IP filter exist in this IP filter list? Or does it exist exactly once? Obviously, you're not going to write all of these. It's just examples. But what I wanted to point out here is if you look at the cost here, it's 37, right? Because it's ANDs, it's true, it's going to run every single expression that you see on the left. On the next slide, the only thing I change is this list of IP filters on the right. But look at the cost here compared to the cost of the next one. So the cost has now gone from 30-something down to 4. And the reason for this is we've provided 2 items in the list, so we're failing on the first expression. Which is nice, because we're not wasting any power computing all of the rest, right? We're failing early. Other things you can do, time-based expressions. So you can write an expression that is only going to be true at a certain time of the day or a certain day of the year. If you have a need for that, maybe for a cron job or something that you only want to give permission for this cron job to run in certain hours of the night. A bit extreme, but it's possible. You might want to write a key that's that restrained. In terms of extensions, because I mentioned you could extend the language, the only one that we've actually implemented at Exoscale is this in-IP range function. Past a CIDR range that you can check if the IP exists. In Kubernetes, there's a lot more of this, right? They have this nice optional field checking here. They have URL functions, more regular expressions. There's a lot more. Basically, check the docs, because, yeah, there's too many to list on here. And, yeah, a crazy example, just to show you what's possible with Cell. So here, we allow rebooting instances in Geneva or Vienna, in these zones, where the request comes from an IP within this range. And they're both IP ranges from Exoscale machines in Geneva and Zurich, where the machine does not have a public IP and whose name starts with dev, is running, and it has these labels, K2, which happens to be my team at Exoscale, and NLB, where the instance was created before a given date, and, just for fun, where the request is made between midnight and 2 a.m., but only within the first 20 minutes of these hours. Whether anyone actually wants to do that, I don't know, but you can do it if you really want. But I think it shows the power of the expression language, because if you wanted to implement something like that without using an expression language, you'd probably have a huge bit of YAML or JSON to achieve that. And it would be a pretty complicated model, I think. Whereas in Cell, I think it's still fairly easy to read if you can understand some basic C-like language. So next, I want to talk about, we know what Cell looks like, what you can do, but how do we actually put this together to form an IAM system or some other system? You could use this essentially if you're exposing an API and you want to just lock that API down. It's a good use case, or for some business rule system. But we introduced the concept of a policy, and a policy is scoped to a certain product category, if you like, at Exoscale. So it could be compute or object storage or IAM. And then for each product, we either say, allow everything, deny everything, or here's a list of Cell expressions, evaluate them one by one, and see if they match. The first one that matches is what you get, basically. And I'll give some examples of that. This is an example from IUI of a policy. And here we're saying, actually, allow every database as a service operation. For compute, allow any read operation in any zone, but don't allow requests if the zone is not in Vienna or Zurich. DK2 is our Zurich zone. Otherwise, allow everything. Deny all object storage, and you get the idea. The same thing in JSON, if that's big enough to read. But basically, it's just an object of services, and you have a list of rules, potentially, for a given service. So compute and DNS here. Essentially the same thing, but simplified a bit. So here we have a list of expressions, and with each expression, we have allow or deny. And the way we evaluate this is we loop through one by one, and we test the expression with the input from the request. If the expression matches, then we look at the action, and we either allow or deny, and we will stop at that point. So if you're doing get zones, you would land on this first expression, we return, and we're done. If nothing matches, then we get to the bottom, nothing matches, we reject the request. But the thing to think about with this is that the order matters, right? Because if I mix deny rules and allow rules, that deny rule has to come before this allow rule for that time to live restriction to actually take place. So yeah, here, the bottom two requests are pretty much, they look quite similar, right? They're both limiting to the same two operations. And you could write them as one expression if you wanted to. I intentionally wrote them as two, just to explain that the order matters. One more example. So what we typically see if you're wanting to allow everything but a certain thing is that you're more likely to write an allow rule of true, allow everything, and then prepend that with some expressions that deny certain things. So here we're only allowing requests in Switzerland, or we're only allowing you to create instances if you use this prefix for the name and if you use this particular security group, which is quite powerful, actually. If you want to ensure that, yes, as a dev team, you're allowed to create instances, create as many as you like, but you have to put the security group on there. And maybe we don't give you permission to change security groups. So one thing I briefly touched on earlier, I think, was the idea that we wanted to do restrictions at multiple levels. So previously, we just had API keys. But then we took that policy from a key and put it onto a role instead. And now we use roles with a policy that looks the same. But you can have a user or a key, and this gets attached to a role. But you also have a policy that looks the same at the organization level. So if you want to deny a certain thing across the whole org, you would do it here. Otherwise, you would just do it directly in a role. And in one more policy that I didn't mention, but we have the same thing at the platform level. So if we want to boot up a new zone somewhere, or we've got a new product that we don't want you to be able to access yet, and we're testing it internally, we can actually apply exactly the same policy at the platform level and control access there. And in order for a request to be allowed on our API, it has to go through every one of these boxes. So it's got to pass at every level. But I think it's a pretty simple concept, but you get a lot of power just from that. Yeah, and so that's pretty much it in terms of the common expression language and how we put policies together. And the last thing I wanted to talk about is how this has actually gone if we face any problems with it. Just for some context, this has been in production for around 2 years now. So it's not really a new thing, even though I'm giving the talk now. So one of the things that people often think is that it's quite daunting when you come to write this policy, because you have to know a lot of things, not just because we use Cell, but if you're building an identity and access management service and you really want to lock things down to fine-grained level, you have to really understand what API calls are happening, which resources are behind those calls, and which parameters we have available. You have to understand the structure of a policy on a given cloud provider. In our case, you need to know the basics of the common expression language. And when you know all of that, you can write a policy. I'd say this is not just specific to our tooling, but typically if you want to write a good CLI, you're going to be doing lots of calls behind the scenes, depending on the API. This is an example of Exoscale CLI, and here it's getting an instance by the name. But typically, if you want to allow this getting an instance by a name on our CLI, you have to add permissions for all of these different endpoints. Because first of all, we list the instances to find an instance with a given name. Then we get the instance, then we go and get a lot of related data to that instance. And of course, you can write all expressions against all of these in a policy and really lock it down. For example, you could restrict which instances you're allowed to list. You might have to provide certain get parameters to filter down to a subset. Documentation is also challenging as well. Just a few screenshots from our docs, but we've got some API docs already. But then when you understand which endpoints you're calling with your tooling, you then need to understand for each one of these actually what's available in terms of Cell, which parameters, which resources. Here we have two different resources. We have a Kubernetes cluster, and we have a node pool of instances. So yeah, there's a lot for people to take in. We went with a kind of cookbook style approach, I guess, just giving lots and lots of examples, which has largely worked well, I would say. But of course, there's always more examples that we haven't given, and people get in touch, and perhaps we help them write a particular expression. But I think generally people tend to understand this after spending a bit of time with it. And it would be true of any complex IAM system, actually. I think it's not unique to the expression language. Tooling is a bit challenging too. And again, this is probably because we went from something that was just a set of operations before to something way more complicated in terms of what you can achieve. So whilst the previous version was quite nice to use on the CLI, I could just give it a few operations that I want to allow. With the next one, actually, I've got to pass expressions, and the way we do that is by passing a blob of JSON at the moment, which is not great, but yeah, if you're using something like Terraform, you have a much nicer experience. Cool. In terms of the UI, writing expressions for sort of MVP, we went just with text fields. But again, ideally, you want some editor here. You want some autocomplete. You want some help in the UI when you're writing this. And another thing to mention is that because you can write all of these time-based expressions and be really fine-grained, we can't really turn sections on and off in the UI or buttons on and off, because the only way that you know whether this thing works is to run it. It's a lot of trial and error. So, next slide. In terms of error messages, right? If no allow rule matches, if you only write allow rules or grants, we can't give you very good error messages back, because the only thing we can say is nothing matched. So we reject the request, and we reject it either at the org level or the role level. If you write deny rules, then we can actually give you a bit more detail. We don't expose the expression in the policy, but we expose the index of the expression, and then you can go and look this up. However, I think we will improve this, because looking at what they do on Kubernetes, the user can provide an error message as well. So we could return an error message provided by the user, which would be a much nicer experience. And I think overall it was a really good choice for us at Exoscale, right? Because given the sort of number of staff that we have, and we built this thing in a matter of months, and that's including writing our own parser. But if you were to go and use the Google parser for Go or Java, for example, you can be up and running with this pretty quickly, I think. And obviously, a lot of the development cost is not actually building this new thing, but it's integrating with what we had already without breaking the customer experience. And of course, there's lots of things that we can improve, particularly our docs. Maybe we can build some tooling like that cell playground, so you can actually test expressions out. Maybe we'll write more extensions in order to make it easier to write expressions. But yeah, I recommend it. I think it's a lot of fun to play with, and it's not difficult, despite it seeming quite daunting, I guess. The thought of the user's going to provide some expressions that I'm going to run in my application, and the immediate question is security implications with that. Anyway, that's me done. Thank you. Go for it, yeah.
Yeah, thanks a lot. How wild are the users usually going with that? So, like, it looks like extremely powerful, but also you can shoot yourself in the foot really bad. Like, how usually?
Yeah. I'll repeat the question. So, how wild are the users going? Like, are they writing crazy expressions or keeping it simple? Honestly, they're keeping it really, really simple for what we see mostly. They use operation in or string starts with. I've not seen any customer write a time-based expression. But maybe that's also on our documentation. Maybe we don't explain that thing enough. But yeah, I think they keep it simple, though. Any other questions? Go for it.
I have a bias for AI, so Have you tried to use the model to simply, write what you want to achieve in a natural, human readable language, in natural language, and then generate these policies?
Yeah, good question. So the question was, have we tried to use AI to help us write these expressions? Not yet, but we could. Although I'm a little bit suspect, because do I really want AI writing an expression that's authorization rules for my API? Maybe. I'm not sure I'm quite that wild, but you could do it. Yeah, anyone else? Or if yeah.
I have a curious question. I'm not really into this field, so I'm just thinking out loud. So you said that testing is a challenge, especially I guess if you have already running systems and you want to introduce this new way of defining rules.
Yeah.
How did you? I mean, for me, that's like a practical issue because you don't want to break legacy and you want things to continue working with something new. So how did you practically go about this? Because you can't just say, okay, these are the new rules. You have to actually test everything that is in place and replace it. So how
yeah,
do you
sure.
do that?
So basically, what was there before? We didn't break it. We left it.
Yeah.
You can still use the old way of doing things if you want, but we put this alongside. However, what we did do, sorry, I forgot to repeat the question. The question was about testing, but I guess there's two aspects to this, right? There's one, how do we test it at Exoscale, this new thing that we've built alongside what we have? But there's also testing in terms of how does a user on the platform test their expressions? And I guess you were referring to the former, not the latter.
Yes.
Yeah. But yeah, basically we didn't break the API we had before. We introduced a new API alongside, new operations on the API. We did actually write something that would translate an older policy into a new policy with the idea of one day migrating everybody onto the new format.
Exactly.
But that was it was trivial to do really because we didn't support very much on the old policies. It was extremely simple. However, if we wanted to go from what we have now to Cell 2.0, let's say, that would be problematic, right? Because users have been writing policies with all these expressions. We can't break that. So we'd have to version policies, or if we wanted to rename something, we'd have to do some translation on the fly of policies.